Yes. Hello everyone. Hi, good afternoon. Okay. Bro, good morning, Allah. It's good afternoon. Good evening. Okay. Yeah. Cool. Hi, hello everyone. Good afternoon. Oh, sorry. Good evening. Okay. So yeah, let us continue with the concept and we'll try to understand as much as possible. Okay. In the last class, if you remember, we were discussing about Bohr's model of hydrogen atom, right? So I'll just very quickly tell you the three postulates. Okay. Cool, bro. No problem. Yeah. So the first postulate what we learned according to Bohr's atom was one, every atom has a nucleus at the center and it has orbits, special orbits called as stationary states, right? In which the electrons are revolving around this particular nucleus. So there is nucleus at the center and electrons will be revolving this nucleus in special orbits, in particular special orbits called as um, stationary states. Stationary states. In this state, they have all the freedom. Okay, there is no problem with them. Even though they are accelerating, there is no need to radiate energy. They are very safe in the stationary orbits, right? Or also they're called as energy levels. Energy levels. Okay, and usually the first energy level or the stationary state is written as K. The next is L, M, N. Similarly, or N1, N2, N3, N4. They are the stationary states or the particular energy levels. Okay, so this was the first uh, postulate of Bohr's theory. And second was that since these electrons are at some radius and they'll be revolving with some velocity, they also have some mass. So therefore, they're rotating, they're revolving, they have some angular momentum. That angular momentum L, which is equal to mvr, is quantized. Okay, yes, Anusha, any doubts? Which will be equal to n times h by 2 pi. Angular momentum of the electrons are always an integral multiple of h by 2 pi. Okay, are always an integral multiple of h by 2 pi. So we have seen this. That means this angular momentum cannot be having a continuous value. For example, if I take 1, 1.1, 1.2, 1.3, I can go in one decimal point to as many numbers as possible. But here, this angular momentum cannot do that. Okay, because it can take only values of 1h by 2 pi, 2h by 2 pi, or 3h by 2 pi. It cannot take 2.5h by 2 pi. It cannot take 2.2h by 2 pi. So they are not possible. Only certain angular momentum is possible, right? Okay, so that was the second postulate which we studied. And the third and the final postulate was whenever electrons move from one energy level to other energy level. For example, imagine this is energy level n1 and this is energy level n2. So when they move from one orbit, one stationary state to one another, what happens is they interact by emitting or absorbing the photon. Okay, so in this case, they're jumping from higher energy level to lower energy level. Okay, then they have to emit the photon. Okay. Or if they go from lower energy state to higher energy state, they'll be absorbing the photon. I'll come back to this in much more detail. I'll tell you why this is a higher energy state, why this is a lower energy state. We'll discuss this in much detail. Okay, we are going to discuss as much as possible, and we'll finalize everything. Okay. So for the first 45 minutes, we'll be discussing about the first and second postulate. Okay, we'll combine both of this, and we'll try to understand what is the radius, what will be the available radius for electrons, and what will be the available angular momentum. We'll try to discuss all of this. Okay, what is the available velocity, what is available energy, we'll all discuss. After deriving the expression for energy, we'll come to third postulate and we'll try to understand as much as possible. Okay, so this was a very quick revision. Before I start with the today's concept, let me ask you a question here. Okay, which of the following cannot be the value of angular momentum in an electron for hydrogen atom? Okay, so I have a nitrogen atom with me, and there is one electron here. So and that electron has some angular momentum L. Okay, which one of this is not the particular value? Okay, electron can take any angular momentum according to Bohr's postulate, but here I have one wrong option. You have to tell me which is that wrong option. Okay, I'll be launching the poll. You can tell me which answer you feel right. Okay, correct, Sura. Correct, Swati. Good. Okay, yeah, take your time. No problem. No hurry. Okay. That's correct. Very good. Awesome. Good. So 20 seconds up. I'll be giving you 40 more seconds. Correct, Pallavi. YouTube guys, what do you think is the right answer? Which one of this is not the angular momentum for an electron in hydrogen atom? Hariprasad Bhargav. Yep. Good. Last 20 seconds, guys. Come on. Zoom, guys. I'll be ending the poll quickly. Okay. Cool. Okay. So let me end the poll, and we'll discuss the answer. Okay. So what's going to happen here is, see, I told you that angular momentum, the electron in a hydrogen atom can take only specific values, and those values are integral multiple of h by 2 pi. So integral multiple matlab n is nothing but an integer. So 1 is an integer, so 1 h by 2 pi. This is possible. 2 h by 2 pi, of course, this is possible. Right. So let me try to arrange them here in the same particular way. So this I can write this as 1 times h by 2 pi, completely fine. This I can write this as 2 times h by 2 pi. Right, I'll multiply and divide by 2. Correct, Madhavi? Yeah, and Bhargav, correct. Yeah. So let me divide this by 2 and multiply this by 2. I'll get this particular option. And notice for here, if I take h by 2 pi outside, that's correct, Surag Mitanka. If I take h by 2 pi outside, what I'll be left with? I'll be left with 3 by 2. I'll be left with 3 by 2. Next is, if I take 3 outside, I'll be left with h by 2 pi. So see here there is h by 2 pi, here there is h by 2 pi, here there is h by 2 pi. I have taken h by 2 pi common from all these options. Now I'll check which of this is integer. So 1 is integer, so this value is acceptable. 2 is integer, so this value is acceptable. 3 is integer, so this value is acceptable. But here I have 3 by 2, which is an integer, so it is not acceptable. Okay. Therefore, this particular value cannot be a right answer. Okay. Cool, right? No problem, bro. Yeah. Good afternoon. Good evening. Good evening. Priyanka. Okay, Hariprasad, am I clear? Yeah. So this is how we can find out. Okay, that angular momentum is quantized. It cannot take all the values which you have. It can take only particular set of values. Okay. Yeah. So now let us begin and try to understand as much as possible what will be the radius of these electrons and what will be the velocity of these electrons revolving around hydrogen atom. Okay. So yeah, the first result which I obtained from Bohr's modulus, as I already revised you 5 minutes ago, is that the electrons can only be available in special orbits or special states called stationary states or energy levels. Okay, and they are given by letter n, which is 1, 2, 3 quantum numbers. In chemistry, in 11th standard, you might have studied principal quantum number n, angular momentum quantum number L, right? So he have studied a lot of things right there. So similarly, I will not use all of this in physics. Okay, this is a principal quantum number, this is the angular momentum quantum number, this is spin quantum number, this is orbital quantum number. We have studied many of this, but we'll only think about this principal quantum number. So what does principal quantum number tells us? It tells us which orbit the electron is rotating. Okay, for example, notice here in the diagram, if I say that electron is present in n is equal to 1 principal quantum number or n is equal to 1 orbital, that means electron is here in this orbit. Okay. If I say that n is equal to 2, that means electron is located in the second orbit. If I say n is equal to 3, that means electron is located in the third orbit. Very simple. So what is the first principle says? That first principle will give us the location of electron. It will give us the location of electron. Okay, there are special orbits, and these orbits have a number of 1, 2, 3, or alphabets K, L, M, N, O, P continuously. No problem. That's correct. Yeah. Okay. So remember this N. You know what is N now, right? Okay. So now let us try to understand. We'll calculate how far is N1 located from the center of the nucleus. How far is N2 located? How far is N3 located? We are going to see how far these shells are existing from the nucleus. Okay. So for that, what I'm going to do? Very simple. So we know that I'm taking hydrogen atom. Okay. For a simplicity, I'm taking hydrogen atom. That's correct, Priyanka. So let me take just the nucleus of hydrogen atom, which is just one proton, and there is one electron, and it is rotating around this nucleus. Okay, it has some mass m. It is located at radius r. It has some velocity v. Okay, this is positive. Electron is negative, so it should be attracted, right? Therefore, there should be some attraction between these two, but they don't have attraction. Rather than the electron will keep on rotating. So why are they not attracting? Is because they have an equal amount of centrifugal force. They have an equal amount of centrifugal force pulling away. Okay, now the electrostatic force is being attracted, centrifugal force is being pulled, both of them balances out each other, and it keeps on rotating without any problem. It is balanced, so there is no translation motion. The radius will not change because in this direction force are same, equal. So if I do that, magnitude of centrifugal force is equal to magnitude of electrostatic force. Both of them are equal but opposite in nature. Okay, so I'm just considering the magnitude. So now, what will be the centrifugal force? It will be mass of electron into velocity of electron square divided by radius of electrons. Okay, is equal to magnitude, right? So the charge of hydrogen is E. Okay, it has one proton, so plus E. It has one electron, so minus E. But I'm considering the modulus. I'm considering the magnitude, so I'll neglect the sign. Okay, I'm going to neglect the sign. So, for example, let me write here as Ze because I can apply for other atoms also, right? Because for hydrogen, it has one proton, so charge will be 1e. For helium, it has two protons, so charge will be 2e. For lithium, it will be 3e because it has three protons. For beryllium, it will be 4e because it has four electrons. Similarly, an atom which has Z protons will carry a charge Ze. So the charge of the nucleus is Ze, charge of the electron is E divided by 4 pi epsilon naught r square. R square. So this is a very simple equation. I'm equating the electrostatic force to the centrifugal force. And now what I'm going to do is I'm going to cancel this r and this r here. Okay, I cancelled. And what I'm left is the master equation. Okay, remember this is very important, and we're going to use this equation very much. Okay, so let me cancel those r. Okay, I'm canceling those two r here. So I'll be getting this particular equation, and this is a very important equation because if you understand this equation very clearly, the derivation becomes much more simpler. Okay, yeah. So I'll call this as equation number 1. Very simple. So next equation, and notice here they have one problem with this equation. Okay, which is mass is constant, Z is constant, 4 pi epsilon is constant, but R is a variable, V is a variable. I have two unknowns. Right? Am I right? I have two unknowns, but I have only one equation. So this is not a proper solution. So what I'll do is I need one more equation to solve this whole situation. And that equation is the angular momentum postulate of Bohr, which is mvr is equal to nh by 2 pi. So this will be my second equation, equation number 2. Okay, if I use this two equation, I can solve for velocity or I can solve for radius without any problem. आराम से मिल जाएगा दोनों variables. Okay, so what I'm going to do now is, if you want radius, okay, so you remember this is my master expression. Okay, if I want radius as the value, what I have to remove? I have to remove velocity. Right, I have to remove velocity if I want radius. So I have to substitute velocity as according to this expression. I'll bring m to the denominator. I'll bring r to the denominator. Okay. Okay. So now I can write velocity is equal to nh by 2 pi mr. Okay. Okay. See, I'll take a new page and I'll do it very quickly. Notice this is one of the easiest derivation ever you'll come across. Okay. So mv square is equal to ze square by 4 pi epsilon naught r was my first equation from balancing forces. Second equation was velocity is equal to nh by 2 pi mr. From mvr is equal to nh by 2 pi, so I brought mr to the denominator. Okay. Okay. So next thing, the final thing, what I'm going to do is I'll put this v here. Okay. So m as it is. What is v square? V square is nothing but n square h square 4 pi square m square r square is equal to, what is this? I'll keep this as it is, z square by 2 pi mr. Okay, see, I just put this v there, and now let me cancel as many things as possible. I want to make this solution simpler. Pi cancel out. Sorry, 1 pi will be cancelled out, not all the pi's. So let me cancel only 1 pi here. Yeah, so 1 pi cancel out. Okay. Yeah, so oh sorry, 4 pi epsilon r. That's correct, bro. Got it. 4 pi epsilon r. So 4 cancel out. Cool. One mass cancel out. One radius cancel out. All of them are out. Okay, so what I'm left with? So okay, let me sort this out. Okay, for your, I don't want to confuse you, so let me do it again. Here this is 4 pi epsilon naught r. Okay, so what I did here was I cancelled 1 4 from here, 1 4 from here, 1 pi from here, 1 pi from here, one mass here, and one mass square here. one radius here and one radius here. Cancel kiya. Okay, now let me see what is remaining. I want radius, right? So I will take this to the right hand side. I'll keep r in the numerator. Here there is n square, h square, no problem. Right? What is here? Epsilon is the denominator. I'll bring it to the numerator. Epsilon to the top side. Okay. Next, what I'm left with? I'm left with ze square. I'll bring it to the denominator. There is 1 pi. There is 1 m. हो गया. So this is the formula for radius of that particular orbit. Okay, हो गया. Solved. Cool, right? So let me write it down. I hope you got it, right? Just you put this v in this expression, you cancel everything, you'll get the answer without any problem. It will be very clear. Okay, so I'm writing it here for your reference in future. If I put this v here, I'll get radius is equal to n square h square epsilon naught divided by pi m ze square. So this is the radius of a particular orbit. Okay, if you want a first orbit, put n is equal to 1. If you want a second orbit, put n is equal to 2. If you want a third orbit, put n is equal to 3. If you want a fourth orbit, put n is equal to 4. And if you want hydrogen, put z is equal to 1. If you want helium, put z is equal to 2. If you want lithium, put z is equal to 3. For beryllium, z is equal to 4. Simple. Okay. Okay. So V now has an expression for radius. But if you notice one thing, so h is constant, epsilon is constant, pi is constant, mass of electron is constant, charge E is constant. If I take Z is equal to 1, all of these are constant except N. All of these are constant except 1, right? And N also takes particular values. N will take the value of 1, 2, 3, 4, 5 only. Therefore, I can quantify this in a very simple way and it's very beautiful. Okay, so let me do it again. Those have any doubt, I'll sort it out very quickly. So mv square by r was equal to z into E by 4 pi epsilon naught r square. This was my formula. I'm going to cancel 1 r and I'm going to cancel 1 r from here. I'll keep this equation number 1. Next formula, next solution is mvr is equal to nh by 2 pi. Therefore, v is equal to nh by 2 pi. Mr comes to the denominator, equation number 2. I'll put this equation here. Okay, m, I have v square here. So I have to square n, I have to square h, I have to square 2 pi square m square r square is equal to this term as it is. Okay, I'm substituting in this term, so this term will be as it is, ze square by 4 pi epsilon naught r. अभी cancel करो भाई. Okay, so m cancel हो जाएगा, m cancel हो जाएगा, 4 pi 1 r cancel हो गया. I'll take this to the numerator. R has gone to the numerator. N square h square remains there. The epsilon naught go to the numerator, divided by pi m stays here. Z square from the numerator comes down. So this is the expression for radius. Okay, cool, right? And all of these are constant. All of these are constant. All of these values are constant here. So I can easily tell you that radius is proportional to n square. Am I right? I can do this, right? Yeah. So the first formula here, Hari Prasad, is the force equation which I balanced. Okay, and this formula here is the angular momentum equation. Mvr is equal to nh by 2 pi from the Bohr's postulate. So I combine these two expressions, I'll get the radius expression. Okay, cool, right? Okay. So now I can easily say that the radius is proportional to n square. So that means for orbit 1, if I put n is equal to 1, I get 1 square is 1. If I put n is equal to 2, I get 4. If I put n is equal to 3, I get 9. If I put n is equal to 4, I get 16. Therefore, I can get a very good clear idea about an atom here. So this is a nucleus. If the first orbit is at some distance, the second orbit is 4 times farther. It is 4 times farther from the nucleus. The third orbit is 9 times farther. Okay, and the fourth orbit is 16th time farther. Okay, it will be very far away, 16th time farther. So I can get this idea. Are you getting the location here? Okay, so something beautiful happens here. See, just by this expression, I can notice that electron can be present here, or electron can be present here, or here, or here. They cannot be present in between. Okay, so always in an atom, electrons are only present at this particular distances. Okay, and we can calculate them very clearly without any problem. Okay, and for example, I'm going to calculate the actual distance for hydrogen. hydrogen Z is equal to 1, I'm going to calculate how far is the first orbital. How far is the first orbital? Okay, so I'll take the same formula, which is R is equal to n square h square epsilon naught divided by pi m z d square. Okay, I'll put n is equal to 1. H is Planck's constant, E is permittivity, pi is 3.14, mass of electron is 9.1 into that particular constant, Z is equal to 1, charge of electron. I'll substitute all of them here. Okay, then if I calculate, I'll get this particular answer, where A is equal to 5.29 into 10 raised to minus 11 meter, or I can write this as 0.5 Armstrong. 0.5 Armstrong. So this is called the Bohr's radius. What is Bohr's radius? If I take an hydrogen nucleus, the first orbital is located at a distance of 5 Armstrong. It is located at a first 5 Armstrong. Am I clear? So then where is the second orbit? Second orbit I have to put n is equal to 2. If I put n is equal to 2, it is located at a distance of 4 times, because n is equal to 1, n square is equal to 1. Therefore, this r for second orbit becomes 4 times. N square is 4 times. So it will be at 2 Armstrong. It will be located 2 Armstrong farther away. Are you getting the idea? How? That was the electrostatic force, Hari Prasad. If you remember, force is equal to K Q1 Q2 by R square, right? K Q1 Q2 by R square. So that was that particular formula, bro. Okay. Am I clear, guys? Did you get what I'm trying to say here? So if you have understood, click on yes. Did you get some idea? Is it any better? So what we did just was, we just found out an expression for radius of an electron. We calculated the first orbital for hydrogen atom is located at 5 Armstrong. Okay. The second is located at 2 Armstrong. The third is located at 4.5 Armstrong. I can tell that very easily by the multiple of n square. Okay. Cool. So let me give you a question, and let me try to let me find out how many of you understood better. Okay. Yeah. Okay. So my question for you now is, okay, imagine, okay, let me give you this question. Yeah. The radius of innermost electron orbit of hydrogen atom is. So we have calculated the Bohr's radius. What is Bohr's radius? Bohr's radius is called the first orbit of hydrogen. The first orbit of hydrogen. Okay, the first orbit of hydrogen is located at this particular value. It is located at 5.3 into 10 raised to minus 11 meter. Okay, so this is the first orbit of hydrogen. Now can you calculate what is the radius of third orbit? Yeah, come on guys, do it quick. So I'll wait for a minute. Try to solve this by yourself. Okay. How far is the third orbit of hydrogen located? Yes, so let me see who will answer me the quickest. So let me write down the formula for radius. Okay, radius is given by n square h square epsilon naught divided by 4 pi, sorry, m pi z square. M pi z square. If you know all of this value, if you put n is equal to 3, you'll get the answer also, not a problem. Okay, but in the problem, they have not given you any information about what is h, what is epsilon naught, what is m, what is pi. So how will you solve this? Okay, imagine you have a very good memory. Okay, then you can calculate radius as the third orbit will be equal to n is equal to 3 square. H is equal to how much? 6.6 into 10 raised to minus 34 square. Epsilon naught is 8.85 into 10 raised to minus 12. All this will be given in the exam. Okay, no worries. Mass will be equal to 9.1 into 10 raised to minus 31. Okay, and pi is 22 by 7, and z is, for hydrogen, z is equal to 1. Charge of electron is 1.6 into 10 raised to minus 19 square, e square. So see, but in JEE you don't have time to solve this question, because if you keep canceling all of these, if you keep solving, it will take a lot of time, right? So this is the right way. You can solve this in this way also, but the thing is, it'll take a lot of time. I can't solve it very quickly. So, but I have a solution. I have a different solution. Okay, which is, see, Rest of these are constant. All of these are constant. This is same. This is same. This whole term what you can see is same. For the first orbit also it will be same. For the second orbit also it will be same. For the third orbit also it will be same. Because the orbit number is here. H epsilon naught, right? M pi z e square. They won't change. They will be always same. So I can tell you that from this expression, R is only proportional to n. R is only proportional to n because all of them are constant. So what I can do is I can write R is proportional to n square. Therefore, R1 by R2 is equal to n1 square by n2 square. I can write in this way, right? Right? So now I want a radius of third orbit, so I'll put a radius of 3, and this is n3. R1 by R3 is equal to n1 square by n3 square. I can write in this particular way also. Z is always 1 for hydrogen. For hydrogen, it is 1. Okay. Here also I'm calculating only for hydrogen atom. So I'll put Z is equal to 1. Okay. So next, for what I want radius of 3. So I'll take it this here. I'll take n3 here. So R1 by n3 square and n1 square is equal to R3. So I'll get this particular. I have brought n1 to the denominator, n3 to the numerator, r3 to the right hand side. What is the radius of first orbit? It's given the question very clearly. It is 5.3 into 10 raised to minus 11 into what is n3? N3 is 3 square, n1 is 1 square is equal to r3. Therefore, this is nothing but 5 Armstrong, right? Or you can easily notice that here 3 square is 9. 9 into 5.3 is 4.77. 47.7 into 10 raised to minus 11, or 4.7 into 10 raised to minus 10, or 4.7 Armstrong. So I can easily calculate that this particular third orbit is located at 4.7 Armstrong distance. Okay, that's correct, Nitanka. I think you missed one digit, bro. Okay, but the decimal point was correct. Cool, right? So yeah, how many of you submitted? Hari Prasad, right? Madhavi, right? Ramakrishna, right? Cool. Yeah. Yeah. So I mean that was very complicated. The blue one, I will neglect that. We'll only follow the red one. Okay, that will be better because we can solve it very quickly without any problem, right? Yeah. I hope I'm clear, right? So see, not just this atom, we can calculate for any atom. And let me give an idea about hydrogen atom. Okay, so hydrogen radius 1 is equal to 0.5 Armstrong. Radius 2 will be 4 times because radius is proportional to n square. So it will be 4 times. 4 times 0.5 Armstrong, which will be 2 Armstrong. Third orbit. Third orbit will be, this is 5.1. I'm rounding off to 5. Okay, I'm rounding off to 5. So this is 9. 3 square is 9. 9 into 0.5 is 4.5 Armstrong. The radius of fourth orbit will be equal to 16 into 0.5 or 8 Armstrong, right? See, as you go farther and farther away, electrons are going far, again farther. Orbit is very far. First, you can find it 5 Armstrong. The next orbit you have to go 4 times farther away for to find an electron in the next orbit. To find the next electron in the orbit, you have to go 4.5 times the distance, right? And next again, to find the fourth radius, you have to go 8 times, right? 8 times, not very far away. 16 times. 16th times the first one. So I have to go much farther here. So this is how you can find the direction of the distance of orbitals. Okay, epsilon is okay, bro. Cool, cool. Okay, I'm a clear. I'm a clear all of with this. So not just for hydrogen atom, for all of the most of them, the orbit as you go away from the nucleus, the orbit also go farther and farther away. They go farther and farther away. Okay, so I'm clear with radius, guys. Note to the formula. Note to the formula for radius. It is very important. We are going to use it again and again. Okay, cool. So if I'm clear, click on yes. I'll derive the formula for velocity. Okay, am I clear? So do you understand radius now? Do you understand how radius of orbitals are located in the atom of hydrogen? Good, good. Okay, better. Okay, so now let us try to understand how the velocity changes. Since the orbit is changing, I'll ask a simple question. So the sun is here, okay, and then you find Mercury, then you find Venus, then you find Earth, then you find Mars. So which of these four planets is moving faster? Which of these is rotating the sun faster? Is the Mars rotating faster or the Mercury rotating faster? Let me see your general knowledge. Which of this planet is rotating faster around the sun? Are all of them moving with the same velocity? What do you think? Which of them is rotating, revolving around the sun in highest velocity, fast? Okay, within which Mars or Mercury or Venus or Earth? So I'm still waiting for answers. Come on, guys. A simple question. Okay, that's correct, Gunashri. The answer is Mercury. Okay, Mercury rotates faster. Okay. As you go away from the sun, the planets become slower and slower. For example, I'll tell you, for this is sun, right? I'll take this as sun. For Earth to complete one complete rotation, revolution around Earth, it will take 1 year. For Mars, it will take 2.5 years. After every 2.5 years, it will complete one round. And even its velocity is very slow. It's covering a lot of distance, I agree, but its velocity is very slow. I can give you a very simple explanation, because the centripetal force is inversely proportional to radius, right? mv square by r. So as you go away from the sun, your force will be less. Force कम हो जाएगा because radius is very less. When radius is less, force will become less. Cool. Right? Okay, I'll prove it to you again in terms of electron. I'll prove it again in terms of electron. Okay. So remember one simple thing. The inner orbital planets are revolving faster. Even if you go to internet and check, I'll find it very easily. The inner orbits are rotating faster. The outer, Pluto is the slowest, but it is not a planet also. So Neptune will be the slowest revolving planet, right? Okay, so similarly, we can also prove that for electrons. We can prove that the electrons orbiting in the inner radius are moving faster, and those who are far away are moving slower. How can I prove that? Very simple. Okay, so we have derived the formula for radius. Yeah, radius is equal to what? N square h square epsilon naught divided by 4 pi epsilon naught. Sorry, not 4 pi epsilon naught. Let me erase it. Pi mz square. Pi m z e square. Okay, cool. Right? No problem, bro. Cool, right? Yeah. So we have got the radius explanation already, and we also had one formula with this. Okay, if you remember, this is equation. This was equation number 2. Let me write equation number 1. mv square is equal to, right? Mv square is equal to. What was the formula? What we got there? Ze square by 4 pi epsilon naught r. So here there was r and here there was r square. I've cancelled one r and one r, and have written equation number 1. So now I've got the radius. Okay, simple thing. You take the radius and put it here in a first equation. I get the answer. Okay, no problem. Okay, so let me do that. Okay, therefore m v square as it is, I'll not change that. Z e square as it is, I'm not going to change that. 4 pi epsilon naught, I'm not going to change. I'm keeping the first equation as it is without changing anything. But instead of radius r, I'll substitute this value here. Radius r is nothing but n square h square. Oh yeah, epsilon naught. And what is the denominator? Denominator of this term will go to the numerator. So here it will become pi m z e square. Pi m z e square. Okay, now what I did was very simple. I took my first equation. I substituted my radius derived formula into the first equation. Okay. Now let me cancel what are the variables. I can cancel m. I can cancel m. I can cancel pi. Pi. Okay. Anything else? Can I cancel? No, I cannot cancel. Z is here. Okay. No, nothing is going to get cancelled here. Okay. Therefore, I can write v square is equal to z into z becomes z square, e into e square into e square becomes e raised to 4 divided by 4 as it is, n square into h square, no problem. And 4 as it is written, epsilon and epsilon becomes epsilon naught square. Okay, I got the expression for velocity. Pi cancel. That's correct. Okay, so I get this particular simple formula. I have square, right? So let me take the square root of whole term. Therefore, I get velocity is equal to z square is z square square root is z A to the power of 4 square root is zd square. Okay, I'm just removing the factor of 2 everywhere. Okay, I'm taking the square root, right? Because I have v square, I'm taking the square root of whole expression. Z square root becomes z. This becomes by 2. This becomes 2nh epsilon naught. So this is the final formula for velocity, right? Yeah, got it. Cancel me. Okay, so this is what you get the velocity formula. Okay, and if you notice, radius was proportional, directly proportional to n square, but velocity is proportional to 1 by n. Is proportional to 1 by n. Therefore, you can easily understand that if n increases, if you go farther away, if n increases, velocity decreases. Velocity decreases. Cool. Like the derivations are very simple only if you understand them. Okay. If you just watch them, I'm pretty sure that you can't do it by on your own. But if you work it out yourself for 2 times, if you work it for 2 times, you'll get the answer without any problem. Okay. Yeah. Even if you don't remember this formula in exam, not a problem. If you're very clear with the steps. So first step is always write the force equation. Equate the centrifugal force to electrostatic force. You get the first expression. Second idea is use the Bohr's second postulate. Okay, combine both of these two, you can get velocity or you can get radius according to your wish. There's no problem. Okay, you can use any method, not a problem. Okay, so what is the result we can draw from this? Okay, so now we are getting much more clear idea about an atom. Okay, so the first idea which we got was this one. This is a nucleus. The inner orbitals are located closer, but as you go away from away and away, the orbit becomes farther. They become very far away, right? But now if you take the electrons, this electron will be moving very fast. This will be slower. This will be much slower. This will be very, very slow. This is slower. This here will be faster. You're getting much more data. You can imagine now how an atom looks. So what we're going to do is we are going to imagine step by step. Acha. So now atoms are very big. They have empty space. Right? You can notice nucleus is very small. The radius are very far. So 99% of atom is empty space. Am I right? I told you this in the initial class. And now the inner orbits, the electrons in the inner orbit are moving very fast compared to those very far. So we are going to build the image of atom in our mind step by step. So by this, if you are going to build by small steps one by one, by the time you go to quantum mechanics, you can understand very much greater about atom. So how does an atom look? How does it behave? You can understand in much more beautiful way. Okay. Cool. And one important result you have to remember is radius is proportional to n square, velocity is proportional to 1 by n. Velocity is proportional to 1 by n. Okay, so therefore I'm going to ask you a question now. What is the velocity of the first electron? What is the velocity of electron in Bohr's radius? In Bohr's radius, that is the hydrogen atom n is equal to 1. In the first orbit, what is the velocity of electron? Can you calculate very quickly? Let me see. Sir, due to more attraction of nucleus, the nucleus shell, so they move slower. No hurry process. So what's going to happen is, see, here there is nucleus and here there is electron. There is lot of attraction because it's very this electron is very close to the nucleus. There is lot of attraction. So to overcome that attraction, it is moving very fast. Okay, but if you go to a bit farther away, this has less attraction. Okay, the electron located here has less attraction compared to this one. So to balance the force, it can move in a slower velocity. If you go to a very farther electron, which is here, okay, this is much farther away, so very much less attraction, so it will move with lower velocity. So if you are near more attraction, to avoid that attraction, you have to move with more velocity because mv square by r, right? If you move with higher velocity, then centripetal force भी ज़्यादा हो जाएगा. They can balance without any problem. Okay. Yeah. So yeah, cool, bro. Okay. So did anyone of you find what is the velocity of electron in the first orbit? Acha. So we know that we have derived the formula for velocity. Velocity is equal to, what's the formula? Z e square by 2 epsilon naught nh. If we solve this equation, we'll get. Okay, so velocity in the first orbit of hydrogen will be equal to, z is 1 for hydrogen, charge is 1.6 into 10 raised to minus 19 into square, right? 1.6 into 10 raised to minus 19 divided by 2 divided by epsilon naught, 8.85 into 10 raised to minus 12 into n is how much? N is first orbit. So I'll put n is equal to 1. What is h? H is 6.64 into 10 raised to minus 34. If I solve this, I'll get the velocity expression. Okay. So let me solve it quickly for you. So here I have minus 12. I'll cancel minus 12. I have left with minus 7. Okay. So I'll cancel minus 7 here and I'll remove minus 7 here. If I remove minus 7, what will I be left with? 27. Yeah. I'll be left with minus 27. I'll take minus 27 and minus 19 here. So I'll be left with minus 8 here. Very quick calculation. You should be very quick about all of this. So 10 raised to minus 8 is in the denominator. Cool. So I'll use calculator and I'll just multiply all of this. What is 1.6 into 1.6 divided by 2 divided by 8.85 divided by 6.6. I'm going to get 0.02. This 10 raised to minus 8 goes to numerator, becomes 10 raised to plus 8. Okay. So if I take two zeros from here and multiply it here, I get 2 into 10 raised to 6 meter per second, or 2000 kilometer per second. 2000 kilometer per second. So this is the velocity of electron in the first orbit of hydrogen. Crazy. Crazy velocity, right? It's not moving 2000 meter per second. It's moving 2000 kilometer per second, and it is not per hour, it is per second. Okay, how fast our rocket can go? If you see our rockets, they can go at a speed of few thousands of kilometer per hour, right? Our escape velocity is 11 kilometer per second, right? But imagine here it's moving 2000 kilometer per second. So electron is pretty fast, crazy fast, right? And yeah, so if I ask you what is the velocity of electron in the 10th orbit? Okay, so this is the velocity of electron in the first orbit. Now I'm going to ask you what is the velocity of electron in the 10th orbit? What are you going to say? What will be the answer? Let me see there are any quick people. Yes, that's correct. It will be 200 meter per second, 200 kilometer per second, because Z is equal to 1 hydrogen, this constant 1.6, this constant 1.6, they stay the same, 2 is same, this is same, but the orbit 1 is often I have to put 10 now for the 10th orbit. So I have to divide this whole equation by 10. Then for 10th orbit, the velocity of electron will be equal to 200 kilometer per second. See, now the farther electron is moving slower comparatively. That's correct, Hariprasad. Okay. So if you want second orbit, put n is equal to 2. If you want third orbit, put n is equal to 3. If you want 10th orbit, put n is equal to 10. The rest of them will be same. So velocity is inversely proportional to 1 by n. Okay, cool, right? You need to imagine. Okay, so I hope you can imagine better how an atom looks like, how electrons behave inside an atom. Okay, cool. Are we good here, guys? Any problem, any issues, any clarification? Okay, before I go on to energy, I want you to be clear with everything what I've told you till now. So all of you should be very capable of deriving the expression for radius and velocity. You should know that radius becomes farther and farther, velocity becomes slower and slower as you go away from the nucleus. Am I clear? Any problem here? Any doubts? Any issues? Or shall we go ahead and derive the energy formula? This energy derivation will be the last derivation. Okay, it will be the derivation will be ending here, and everything will become simpler as we go on. Okay, cool, awesome, guys, great, no doubts. So yeah, the last thing what we're going to do is to derive the expression for energy. Cool. Okay. So now we have two expressions with us. So we'll remember them. Okay, we'll not forget. So the first expression which you derived is radius. Radius is equal to n square h square epsilon naught divided by pi em z square. Remember this. Try to remember this. Okay. Don't by heart, but by practicing, I think you'll get it in memory. Okay. And velocity of electron is how much? What was the velocity? Z square, right? By 2 epsilon naught n pi. Sorry, nh. Image. Okay, so I'll derive these two formulas. No problem, no worries, right? So now I'm going to write an atom here. So there is this nucleus, and there is one orbit, random orbit n, and there is this electron revolving around this. So this has some velocity, and this is located at some distance r. So therefore, this electron is moving. Therefore, the total energy of this atom will be having kinetic energy and also will be having potential energy because it has some charge. It has some charge, both 2000 nan per n. That's only for hydrogen, bro. Yeah, you can do that, Hari Prasad. Not a problem. You can remember that also. Okay. Yeah. So therefore, the total energy of this electron will become kinetic energy plus potential energy. What is kinetic energy? We know that kinetic energy is equal to half mv square. Half mv square. What is potential energy? If you remember the formula for potential energy, U is equal to K Q1 Q2 by R. You remember from electrostatic chapter, right? So this is the potential energy of a charged particles. So here this is positive charge, this is negative charge. So therefore, um, K is nothing but 4 pi epsilon naught. R is the radius. Charge 1, charge of proton is Ze, charge of electron is minus E. Charge of electron is minus E. Okay. If I solve this problem very slowly, and by substituting the values of V and R from the above two expression, I'll get a energy formula. And it's pretty easy. Okay, it's quite lengthy, but it is easy. Okay, let me do it completely. Therefore, D is equal to, I'm writing half m as it is, no changes. What is V square? V square is Z square e raised to 4 epsilon naught square n square h square. I've squared this whole term and put it here. Bas, ho gaya. Negative of negative is, well, negative of positive is negative. Here I get Z e square. Okay, by 4 pi epsilon naught r as it is. But instead of radius r, I'm going to substitute this formula, which is n square h square epsilon naught and pi m z square in the numerator. Ho gaya. Okay, so can I cancel anything here? Yeah, I can cancel pi and pi here. Okay, that's all. I cannot cancel anything else. I'll leave it everything there only. Therefore, total energy will become what is this? 2 4s are 8 in the denominator. Okay, in the numerator, mass z square e to the power of 4. In the numerator, the epsilon naught square n square h square. Simple. Minus what is left here? Z e square z e square. It becomes z square e to the power of 4, and mass as it is, I'll keep m here. Divided by 4 epsilon naught n square h square. हो गया. So this is the formula for total energy. This is the formula for total energy. But one thing, if you notice very closely, very slowly, uh, here these many things are constant. See, this whole term here is very much similar to this term. There is no change. They have exactly same. So I'll take this as constant. I'll bring them outside the bracket. Okay. So if I bring them outside the bracket, what I'll be left with? I'll be left with 1 minus 1 by 8 minus here what I'm left with 1 by 4. What is 1 by 8 minus 1 by 4? It becomes minus 1 by 8. So the final answer of energy is minus m z e to e square to the power of 4 divided by minus 1 by 8 epsilon naught square n square h square. Okay, so this is the total energy of a single electron in the nth orbit of a z atom. Okay, the red box here is the formula, final answer. For other also, shall we write as z? Yes, Hari Prasad, we can do that. Okay, cool. So I hope you're clear with the formula. The derivation is very simple. Total energy is equal to half mv square plus potential energy k q1 q2 by r. Put the expression for velocity and put the expression for radius. Solve the equation. Okay, mix it, solve it. You get the answer, final answer. Simple. Okay. Am I clear? And one most important thing, what we need to understand here, what we need to remember here is why there's a negative sign. So let me ask you a question. Why the energy is negative for the electron? Have you seen the negative term? Energy is scalar quantity. Energy can never be negative, right? If you mean the displacement is negative, if you mean displacement is negative, that means it's happening in the left side direction. But distance cannot be negative because it is scalar. Similarly, energy is also scalar, and then energy is not a vector quantity. But why did I get negative here? What is the meaning of it? Is there any importance of this? What do you think, guys? Anybody have an idea why energy is negative? Energy is released exothermic. Bro, you went to chemistry. Okay. Yeah, there's epsilon square here. Yes. It's attraction. That's correct, Gunashi. One is, yeah, that's correct. I got it. I got it. So exactly, if you remember gravitation chapter, all right, even in gravitation, we get the same concept here. Okay, which is if sun is here and if earth is located somewhere farther away, its total energy will be minus gmm by 2r. We also got negative total energy for earth. Even imagine if you take a satellite, revolving around earth. If you find the expression for that, you will get the same answer. Okay, it will be negative, but here we have to consider different masses and different radius bus. But whenever you see negative term in energy, that negative term indicates that it is bound to the system. It is bound to the system. It is bound to the system. Okay, that means it cannot go away from this Earth, planet Earth. We cannot sun's orbit. Similarly, the satellite which is revolving around Earth also is kept in the orbit. It cannot go away because its total energy is negative. Okay, so same thing. So what I was trying to say here is imagine. So I am on the Earth, which has some mass m. Okay, and my mass is small m. My mass is small m. I cannot leave the earth unless I do some work. I cannot leave the earth. I cannot escape the earth because I am attracted to the earth by a total energy of minus g times earth mass, my mass divided by radius of earth, 2 times radius of earth. So by this much amount of energy, I'll be always bound to the earth. Only if I give this much amount of energy to my body, I can escape the gravitational pull of earth and I can become free. I'll be floating in space. Okay, are you getting my point? So negative means it is bound to the system. Similarly, whenever in an electron there is nucleus and in the first orbit there is electron. Okay, if this has some negative energy, that means it is bound to this nucleus. It is always revolving around the nucleus. Only if you provide some energy by thermionic emission or by photoelectric emission, by or secondary emission or by field emission, you can remove this electron only by that four processes which I told you in the photoelectric class. Okay, does it make sense? What I was telling you just by statement in the old classes will be making much more sense. Right, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಅರ್ಥ ಆಗ್ತಾ ಇರುತ್ತೆ, right? I hope. Okay, cool. Okay, so we know that radius is proportional to n square. We know that velocity is proportional to 1 by n. How is energy proportional to what happens to energy? So energy formula, we know that it is minus 1 by 8 of mz square, mz square e to the power 4 divided by 8 epsilon naught square n square h square. So energy is proportional to minus of, okay, if I mass of electron is constant, yeah, I'll put z is equal to 1, I'll put e is equal to 1.6, 8 is constant, epsilon naught is constant, h is constant. When I solve all of this, I get 13.6 electron volt. N is not constant, so I'll bring this n outside. So this is the energy of an electron in hydrogen, for hydrogen, because it is z is equal to 1, right? Z is equal to 1. Yeah, am I clear? So this is what's happening. Energy is proportional to minus of, energy is proportional to minus 1 by n square, or energy is equal to minus 13.6 by n square, minus 13.6 by n square. Cool, am I clear about this? Okay, I think you have seen this number very much already in chemistry. Yeah, cool, right? Any issues, guys? Am I clear completely? So these are three relations which we need to understand very clearly. Okay, come on, give me a yes or no. Waiting for your response. Good. Awesome. No doubts. YouTube guys? Cool. Awesome. Okay, so now we know that radius becomes bigger and farther as we go away. Velocity becomes smaller and smaller as we go away. What happens to energy? We'll try to get the physical meaning. We'll try to get the physical meaning of energy. Okay, so give me a second. This problem is solved. Yeah, so now I'm going to draw something called as energy levels. Okay, so there is a proton here with one positive charge. There is electron in the first orbit. Okay, so if I want to calculate its energy, I'll write it as E1. Okay, E1. And the first orbit is always called as the ground state. It is called as the ground state, the base state. Okay, if I take the second orbit, it has some other energy. I'll write as E2 for N2 orbits. Okay, for the third energy level, I'll take n is equal to 3. For the fourth orbit, I'll take energy is equal to some other value E4. It will be having n is equal to 4. Okay, so I'll keep on increasing the value of n, and I'll go up to n infinity. What does n infinity means? N is equal to infinity means that the electron is free. Electron is free. If n is equal to 1, that means it is bound in the first orbit. If n is equal to 2, that means the atom is bound, the electron is bound in the second orbit. If n is equal to 4, the electron is bound in the fourth orbit. If n is equal to infinity, that means the electron is out of the atom. It's completely free now. Okay, so that is a general notation which we are going to use. Okay, so now let us calculate what is the energy of first state, what is the energy of second state, what is the energy of third and fourth, so on. Okay, so yeah, so I know this formula. I already told you this. Energy is nothing but minus 1 by 8, right? Mass z square e to the power of 4, right? Epsilon naught square n square h square. If I solve all of this and if I keep only n outside, I'll get energy is equal to minus 13.6 by n square electron volt. For first orbit, I have to put n is equal to 1. If I put E is equal to 1, right? So minus 13.6 by 1 square electron volt. The first orbit will have the energy of minus 13.6 electron volt. If I take the second orbit, energy of the second orbit will be equal to minus 13.6 by 2 square is 4, which is equal to how much is this? Minus 3.4 electron volt. Okay, if I take the energy of third orbit, it will be minus 13.6, third orbit square is 9, minus 1.5 electron volt. Energy of fourth orbit is equal to minus 13.6 by n, sorry, 16 by 16, which will be equal to minus 0.8 electron volt. What is the energy of infinite orbit? What is the energy of an electron which is outside the atom? What will be its energy? What do you think the energy of the atom which is completely free? 0, right? Because I'll be dividing this by infinity. Infinity square is almost very big number. It is almost like a very large number. When you divide a small number by a very big number, it tends to 0. It will having 0 electron volt. Therefore, free electron has a charge has an energy of 0 electron volt. The first orbit energy will be minus 13.6 electron volt. The second orbit will be minus 3.4. This is minus 1.5, and the fourth is minus 0.8. I think you have seen these numbers in chemistry in more cases, right? Right? Yeah. So this is how we did, and we have found out all the different energy levels. Okay, here are they. All the different energy levels are here. So why am I telling you this? Why is it important? Because imagine there is one electron in the first orbit here, in the first shelf, in the first energy level. If you want to bring this electron outside the atom, if you want to bring it to free state, how much energy you have to provide? How much energy do you have to provide, you think? If you want to bring this electron, which is having an energy of minus 13.6 electron volt to the final state, the amount of energy you need to provide is plus 13.6. If I provide plus 13.6 electron volt, add both of them. Initial energy was minus 13.6. I'm sending a photon. I'm sending a photon which has an energy of 13.6 electron volt. So this electron will absorb all the energy from the photon. Its total energy becomes 0. 0 matlab where it has to be? It has to be outside the atom. Outside the atom. So this is called ionization. Ionization. Do you remember chemistry? Ionization energy of hydrogen atom is 13.6. This is how we get 13.6. Okay. So how to do the calculation? Very simple. Okay. So I'll tell you. You have to make sure initial energy is equal to final energy. You have to conserve energy. Okay, what is the initial energy? Initially, it was in the first orbit, so that electron has minus 13.6 electron volt, and I'm heating this with some photon of energy x. I'm colliding this electron with some photon of energy x, will be equal to final energy. For free state, final energy should be equal to 0. Put that 0. Therefore, you get x equal to minus plus 13.6. Minus comes to left hand side, become positive. That means the energy of photon should be equal to 13.6. If you send this much amount of energy, you will get the electron to come outside the atom, and that is called as the ionization energy, right? Okay. So similarly, what going to I'm going to send the electron which was in the first orbit to electron in the second orbit. Okay. So the process of going to higher orbit is called as excitation. It is called as excitation. This is called from one level to other. Okay. So what is ionization then? Ionization is simple. Ionization is from one level to outside the atom. To outside the atom. If it go outside the atom, it is called as ionization. If it go from one level to other level, it is called as excitation. Okay. So now I'm going to ask you, what is the amount of energy required to send an electron from n is equal to 1 orbit to n is equal to 2 orbit? How to do this problem? Very simple. Again, I'm going to equate initial energy is equal to final energy. What was the initial energy? The electron had an energy of minus 13.6 electron volt. And I'm going to give some photon here. I'm going to send a photon here which has some energy x is equal to it is going to the second orbit. Second orbit में energy कितना होगा? It will be having energy of minus 3.4 electron volt. Therefore, x is equal to minus 3.4 minus 13.6 become plus 13.6 when it comes to right hand side. Solve this out, we'll get 10.2 electron volt. So if this photon has an energy of 10.2 electron volt, this will go to second orbit. If it has energy of if the photon had an energy of 13.6 electron volt, then it will go to the outer bounds unbound state. So this is how we calculate how much energy exchange will happen from one orbit to other orbit. So by this simple formula of energy conservation, you can find out any transition from n3 to n4, from n10 to n11, in any orbits. You can do any orbit. Okay, but remember, you take the energy here, okay, and you are sending it to this electron. This electron is going to absorb and go to higher energy level. Okay, and you might ask me, sir, which is the higher energy level, which is the lower energy level? I can tell you that this here is the lowest energy because it is minus 13.6, and this is a bit higher. This is a bit higher. This is the higher energy levels. These are higher. Okay, and this E is equal to 0 is free. If an electron wants to go from lower energy to higher energy level, it has to absorb energy. Now, how can you increase the lower value? You can increase the lower value only by absorbing energy. So whenever you're sending electrons from lower orbit to higher orbit, it has to absorb the energy. Cool. We have to remember the graph values. Yeah, it is better if you remember these four numbers. Okay, or you just remember this formula, minus 13.6 by n square is equal to energy. If you remember this formula, it is also fine, not a problem. Put n is equal to 1, 2, 3, 4 according to the orbital. Okay, okay. So now what I want you to remember is, if an electron wants to go from a lower energy state to higher energy state, क्या हो जाएगा? Only if by absorbing a photon. Okay, for a lower energy electron, you are going to send a photon, it will absorb, it will go to higher energy level, and this is called as excitation. It's getting excited because it's absorbing energy. And the reverse is called as emission. Okay, if an electron is coming from this orbit, the third orbit, to the first orbit, if it is coming from higher energy to lower energy, it is going to give out electron. Sorry, it is going to give out photon. Photon emission ho jayega. Okay, so how does it happen? How much photon will it emit? So if you notice, here it is 1.5, here it is 13.6. So what will be the energy? Again, we'll balance energy conservation. Energy initial will be equal to energy final. Okay, what was the initial energy? Initially, this electron had an energy of minus 1.5 electron volt. 1.5 electron is equal to final में क्या होगा? Final में it is coming to this orbit. So it has an energy of minus 13.6 electron volt, and also finally it is emitting a photon of some energy x. So if I send this minus 13.6 to the right hand side, I'll get plus 13.6 minus 1.5, 1 is equal to x. Or I'll be getting approximately 12.1, 12.1 electron volt. So here, now in this process, a photon of 12.1 electron volt is being emitted, and this process called as emission, spontaneous emission. Emission. Am I clear? And you might have noticed it only depends on the energy gap. It depends on the energy gap. Okay. So what I was trying to say to you here is, so I'll give you a question now. Okay, guys. So this, how much was this? This was minus 3.4. What is the gap here? The gap between these two is, this has energy of minus 13.6. This has minus 3.4. The gap is 10.2 electron volt. Okay. The energy gap between the first orbit and the second orbit is 10.2 electron volt. Okay. So now I'm going to ask you a simple question. If this photon, which is at this level, okay, if it wants to go to this orbit, how much energy of photon have to submit? Yeah, come on, quickly. How much energy should I submit to this particular electron so that it will go to second orbit? Yeah, come on, quick. Pallavi, Nitank, good. Okay, so it will be giving. I'll be, sir, we have to remember the graph. Okay, that's one question. Exactly. So 10.2 electron volt is the right answer. Okay, because you can use the conservation of energy. Okay, initially minus 13.6 plus photon is equal to 5, then minus 3.4. Therefore photon का energy क्या होगा? Minus 3.4 plus 1, 13.6, 10.2 हो जाएगा. So the amount of photon which is going to be absorbed is equal to the energy gap. इसमें energy gap कितना होगा? That will be the energy. Therefore energy of level 1, okay, minus energy of level 2 modulus will be equal to energy of photon. This is general formula. What is the energy of photon? The energy of photon which is coming out or which is going to get absorbed, both in emission and absorption, will be equal to the energy gap difference. Okay, similar, same thing. If a photon is in this particular higher orbital, if it is coming down to the this orbital, it will emit a photon of 10.2 electron volt. Oh yeah, bas. No change, no change. If the electron was in the lower level, if you want to send it, you have to send an electron of 10.2 electron volt. It will absorb that photon, the electron will jump. Or there is a higher electron here. If you take out 10.2 electron volt from this, it will jump to lower orbit. So always the interaction of photon, the energy of photon will be equal to the band gap between the orbitals. It will be equal to the band gap between the orbitals. Okay. So for example, if they might ask you a question, what is the, how much energy should I provide to send the electron from first orbital to eighth orbit? To eighth orbit. They ask you this question. Okay, then what you will do? You know that energy of photon is equal to modulus of energy of first orbital En1 minus modulus of energy of eighth orbital. I'm putting modulus, okay, because it is scalar quantity. So this I'll get minus 13.6 by n orbital is 1 square minus as it is minus 13.6 by 8 square is 64. Okay, if I solve this, I can easily find out how much energy I'm supposed to give such that it will go to the eighth orbital. 13.6 by 64 is 0.2125. So 13.6 minus 0.2125 is 13.385. Therefore, the final answer comes to be 13.38. So if I provide this much amount of photon to this electron in the first orbit, it will go to the eighth orbit. It will go to the eighth orbit. Cool, right? Am I clear, guys? Am I clear? This is one of the most important concept. Usually they keep asking in JE also, right? They'll be trying to ask you what is the amount of photon or the amount of energy you need to find out. Okay, when one orbit to one orbit transition hoga, they'll ask you. Okay, once if you found out the energy, you can also find out the wavelength. वो भी मिल जाएगा आराम से. Okay, because I know that energy of photon is equal to h nu, and that is equal to energy of one orbit, right? Energy of one orbit minus energy of the other orbit. energy of the other orbit. If you use this formula, आराम से मिल जाएगा. Okay, if you want wavelength, what you'll do if you want wavelength? H as it is, nu is c by lambda. It is equal to E1 minus E2, or 1 by lambda is equal to 1 by hc, E1 minus E2. Okay, or simply we have one formula. Okay, we have one formula which is Rydberg's constant R into 1 by n1 square, okay, minus 1 by n2 square, because E can be written as 1 by 13.6 by n1, E2 can be written as 13.6 by n2 square. You bring 13.6 here and you solve this whole constant wala thing, you get Rydberg constant, and this is the formula, okay, to find out the wavelength of light. So what I'm trying to say, let me write all the formulas related to this chapter. Energy of photon is equal to E1 minus E2. Okay, that will give you the energy, it will give you the frequency. If you want lambda, you use this formula. 1 by lambda is equal to Rydberg constant into 1 by n1 square minus 1 by initial minus final square. Okay, if you use this formula, आराम से मिल जाएगा. Okay, if the electron is going from first orbital to 8th orbital, you put n is equal to 1, nf is equal to 8. Okay, if the electron is going from second orbital to third orbital, if you put n1 is equal to 2, n3 is equal to 3. Okay, so you'll get the answer. Rydberg constant is 1.097 into 10 raised to 8. 10 raised to 8 or 6. I'll show you that value. Okay, I hope it is 9. Okay, it is a constant value. I'll tell you what the constant value is. So you can find out the energy between the transition of photon. You can also find the wavelength of photon. You might ask me, sir, how did I get this formula? It's very simple. Okay, because if you notice, h nu is equal to E1 minus E2. Okay, hc by lambda is equal to E1 is how much? Minus 13.6 by n1 square. What is this one? This is nothing but minus 13.6 by n2 square. Right, I'll guess this particular formula. And if I take hc 1 by lambda, I'll keep it as it is. I'll bring hc to the denominator. Okay, if I take everything common, so I'll take minus 13.6 also common. If I take minus 13.6 common, what I'll be left with? 1 by n square minus 1 by n2 square. This whole thing is called the Rydberg constant, and it is equal to R. See, you get this particular simple formula. Again, derivation is not much important. Okay, but you need to understand how do you get the formula. Okay, cool, right? Any doubt, guys? Oh, my phone is switched off. Yeah. Cool, right? Any problem, any issues? Am I clear, or did I, tell you a lot of things, or do you need any clarification? If you have any doubt, let me know. Okay, YouTube guys, Zoom guys. You want me to revise anything? You want me to clear anything? You want me to clarify anything? And sorry, YouTube guys, I can't see your comment because my phone is switched off. Okay, let me try and open another laptop. Sir, why the formula is in modulus? Because if the energy is being out, if I want the electron to go from lower orbit to higher orbit, I'll be giving the electron, I'll be giving the photon, so it will be positive. If I send the electron from higher orbit to lower orbit, I'll be getting the energy, so then it will be negative. Okay, modulus means photon will always be having a positive energy, bro. That's all. Photon can never have negative electron volt energy. Photon always have positive energy. If you get plus 10.2 electron volt, that means you are giving the photon. If you get minus 10.2 electron volt, that means you are getting the electron from, you are getting the photon from the electron. Okay, okay, okay. Any doubt, guys? Zoom guys, am I clear? No issues, right? Okay, cool then, cool. So if you have any doubt, let me know. I'll be sorting it out very clearly. If you want me to do any derivation again, or if you want me to clarify some concept. Okay, so shall we complete the chapter? Shall we revise it? We'll put all the ideas just in one slide. Okay, wait, sorry. Okay, so I'm going to solidify all the ideas just in one slide. Okay, so pay some small attention here. Okay, so this is the nucleus of an atom. Okay, and I'll be repeating few things, but don't worry. So first orbits are closer to each other, right? And as you go away, the orbit becomes farther and farther. It becomes very much farther away. Okay, yeah. So this is how far this particular orbit is, and the radius here, this radius is a function of n square. So it is becoming farther and farther. And if I consider the electron which is moving with some velocity v, this will be moving much slower, this will be moving much faster, this will be moving more faster. Okay, and velocity is proportional to 1 by n. As you go far away, velocity becomes low. Okay, and when one electron jump from higher energy level to lower energy level, it will give out a photon mil jayega, right? And similarly, when one electron which is here in this orbit absorbs some energy from photon, it will jump to higher energy levels. So jumping to higher energy level is called as excitation. Coming back to its lower state is called as emission. It's called as emission. Okay, and we have calculated the formula for velocity, radius, and also for energy, and we know that energy is proportional to 1 by n square minus 1 by n square. Okay, so these are the lowest energy levels, and as you go higher, you get higher energy levels. And if I go to n is equal to infinity, that means energy is equal to 0. That means it's a free atom. Sorry, it's a free electron. Electron is free now from the total system. It's completely free. Okay, yeah, and we can also calculate the wavelength of this light of these photons. Okay, by using a simple formula. I just took this formula. Okay, and I just manipulate it and I get the formula. E of the photon is equal to E2 minus E1 or E1 minus E2 modulus. Okay, if you are exciting, you have to give the energy. If it is emission, it will give out the energy. You remember that. Later on, if I want 1 by lambda is equal to Rydberg constant into 1 by n initial square minus 1 by n final square. Both the formulas are exactly same, but slightly modified. He is equal to hc by lambda. E1 is proportional to 1 by n square. E2 is proportional to 1 by nf square. They're exactly same, but they're modified in a slight simple manner. Okay, so this is the whole class of today. This is what I've been teaching you the complete day with these 3 derivations. Okay, and the syllabus for JEE has been already announced in JEE mains website. I already told you, right? I hope you have checked. There is not much difference in the syllabus. If you notice clearly, except like 1 or 2 words in the syllabus, there is not much change. It's almost same. It's almost same. Okay. So go through it and please check once again. Not a problem. Okay, relationship between kinetic energy and energy. Yeah, I'll be getting back to that in a moment. Give me a second. I mean, since I was opening the black screen, I was unable to see your chat box. Let me answer it now. Okay, so there's a student. Okay, there's a question. We have to find a question between energy and potential energy and kinetic energy. So what you do is very simple. Okay, we already know the energy formula. What is energy formula? Energy is equal to total energy is minus mz square e to the power of 4 divided by 8 epsilon naught square n square h square. So this is the formula of energy, total energy. So what is kinetic energy then? So kinetic energy is k half of mv square, half mass. What is velocity square? Velocity square we already derived, right? Velocity square is nothing but z square e to the power of 4 divided by 2 square is 4 epsilon naught square n square h square. Okay, 2 fours again it will become 8. Therefore, you can notice that the total energy of the electron is equal to negative of kinetic energy. It's equal to negative of kinetic energy. They're same. Okay. Total energy is exactly equal to kinetic energy, but with a negative sign. In kinetic energy, half mv squared is positive, but total energy is negative. Okay, so they are equal, but with a negative sign. And what is the energy between potential? Let me find a formula for potential energy. Potential energy U is equal to Z E square, right? Q1 Q2 by 4 pi epsilon naught into radius. Radius kitna hoga? Radius is n square h square epsilon naught, right, into Z E square m. This is very simple. U is equal to nothing but mz to the square e to the power of 4 by 4 pi epsilon naught square n square h square. Okay, cool, right? Yeah. So mil gaya. And pi, so there's pi here, pi get cancelled out, and I'm left with pi remove ho jayega. So if you notice the relation between kinetic energy and potential energy, this is 1 by 8, this is 1 by 4. Matlab, if you multiply kinetic energy by 2, just imagine, if you multiply kinetic energy by 2, 2 से multiply करेगा, 2 1 जा 2 4 जा, क्या मिल जाएगा? Potential energy मिल जाएगा. Therefore, 2 times kinetic energy is equal to potential energy. Okay, and what is the relationship between this formula and this formula? You can notice that energy and potential energy are exactly same, but here it is 1 by 8, here it is 1 by 4. So if I multiply this, or you can check here, E is equal to minus K. So replace K by minus E. So minus 2 times E is equal to U. So you can form as many relations as possible. Cool, Anusha, am I clear now? So you can just compare them. You can just keep multiplying them, and you can get the answer. Okay. So therefore, energy and kinetic energy are equal to each other, but with a negative sign. Okay. Energy and potential energy are double of each other. Total energy and potential energy is differ by a factor of 2, right? Kinetic energy and potential energy also differ by a factor of 2. Kinetic energy and potential energy also, sorry, potential energy and total energy also differ by a factor of 2. I hope I'm clear. Okay, cool, awesome, great. Cool, guys. Then, so there is one small change. Okay, the small changes from Monday. There is some more students are going to be added to the batch. So I'll be. I am asked to start a new chapter. Okay, they want me to start a new chapter from Monday. So I am going to just withhold one small topic. One small topic. I'm going to skip this spectrum part for a few days. Okay. Maybe I'll take some special class and I'll finish this off part someday. Okay, but from Monday, I'm supposed to do modern physics. Sorry, nuclear physics. I will study nuclear physics. What is proton? What is neutron? How do they exist in the nucleus? We're learning about electrons in an atom. Now we're going deep into the atom, into nucleus. Okay, we'll see what is radioactivity, what is nuclear fusion, what is nuclear fission. It may take 2 classes to complete that again. Okay, so today is 22. By next Wednesday, by Tuesday, this chapter will be over. I'll be finishing 2 units of nuclear physics. So modern physics will be completed, except the spectrum part, and we'll move on to semiconductors. Or yeah, we'll move to semiconductors very quickly. So therefore, only one chapter will be remaining, part 2, ray optics, if I complete semiconductors. Okay, cool, right? So sorry, I couldn't see any YouTube downloads because my phone is completely gone. Sorry, Hari Prasad. Let me explain here. Sir, why modulus and formula ho gaya? Understood. Write all the topics and formulas. Okay, bro. I'll do that at the end of this chapter. Okay. Uh, After even when I finish the modern physics, the nuclear physics. Okay, sir. Devil also have molecules, atoms as humans. I don't know whether devils exist, bro. So I'm not sure. Cool. You can't comment on something which you have never seen, right? Yeah. Cool. Okay. Bye bye. See you all. Take care. Meet you on Monday with modern physics. If you have some time, try to read on the spectrum part. What is emission spectrum? What is content spectrum? We'll try to read it by yourself, and we'll get back to nuclear physics on Monday. So, bye bye.